So now what I want to work with is the basic substitution method, but this time with definite integrals. So remember, with definite integrals, we're integrating from a certain value to another value. But when you think about that, those values only apply if it's x for dx, right? So if you change the entire equation in terms of u to du, that means you also have to change the limits as well. It only makes sense that if you change the equation, that the limits itself will change, okay? And this is a really common mistake that everyone forgets because you're just very used to changing this, but remember, definite integrals, a main part is changing these units as well. So let's see that in practice. So we want to find from 0 to -1 of this equation here, and we want to let u equal to 1 plus x, okay? So as with the previous questions, first thing we want to do is differentiate this. So we get du on dx equals to 1. The x just becomes a 1. Flip that, du equals to dx. Now, because that's going to leave us with an x left over, we're going to have to find out what x equals to from this equation. So x just equals to u minus 1. And now I'm ready to substitute in. This here is for limits. So remember, for definite integrals, you always have to change the limits. We always start off with the top one, so x equals to 0, and you just substitute it back into this equation. So when x equals to 0, u will just equal to 1 plus 0, so it's going to equal to 1. Whereas when x equals to -1, you're going to have u equals to 1 minus 1, which equals to 0. Can you see how it's important to change what the limits are? Because the limits here, the x values here, also have to be subject to the change over here. So now we've done limits as well as the du and dx and worked out how to get rid of that x up there. We can substitute it in. You have this 1 plus x, and that just becomes your u here. Whereas when you have this 0 minus 1, that comes from this x over here, because we worked out that x equals to u minus 1 there. And finally, let's look at our definite integrals here. So from 0 to -1, but remember we changed that to 1 to 0. Can you see that? So essentially, when you're working with definite integrals, there can actually be 3 things you need to substitute. So this, and also the dx for du, and also the limits as well. So remember 3 things when it comes to definite integrals. And now from here, you can just expand and integrate. So u to the power of 10 times u gives you u to the power of 11. U to the power of 10 times that is negative u to the power of 10. And we just integrate that. So power of 12 on 12, power of 11 on 11, and substituting in 1 will give you 1 on 12 minus 1 on 11. And when you substitute in 0, you essentially just get 0 minus 0. So we haven't bothered to write that there. And just pop that in your calculator, and you should get -1 on 132. So the important things to note for this question is this extra step over here, which was to work out the new limits. And I think if you understand why there needs to be new limits, because we're changing the entire question, it's easier for you to remember, because you're not just remembering the steps to do a question, you're actually understanding why we're doing it.